Hello. In this lesson, we're going to talk about solving quadratic equations. Before we solve quadratic equation, we like to review about quadratic functions, right? So what are quadratic functions? Say we study that quadratic function looks like this, where a, b, c can be any number you want, but a cannot be 0. We also talk about that quadratic function can be transformed, right, into a complete square as part of it, and also with some other numbers attached to it, and also a vertex will be determined. And we have also discussed that how do we know if the quadratic function crosses the x-axis, how many times, and so on and so forth, okay? To be sure, look at the first case, right? So for this quadratic function, okay? If the discriminant is positive, right? And we say the parabola is going to be cross the x-axis twice. And how do they cross the, how does a parabola cross the x-axis, right? So I'm going to give you the cases of that. Okay, so let's just look at these concrete cases, right? Now we're going to see the cases where the parabola crosses the x-axis twice, okay? One of the cases, it opens up, right? So we could totally have a quadratic function that opens up, right? So let me give you an example. We've seen, and I'm just taking some random examples and graphed it. You can see this quadratic function crosses the x-axis twice. And this is actually the example we did earlier, right, in the previous lessons. And let me just make a little bit adjustment so it looks nicer, okay? This is going to be something like that. How does that look? Yeah, so this is the case where the discriminant is positive, right? The curve opens up. The curve could also open down. For example, I can totally have this, this curve opens down. Okay, let's see if that opens down. Well, this opens down but doesn't cross, right? So I want the case that the cross. So something like that. This time it should cross. So these are the two cases, right? These are two cases. One case, it could be A is positive, right? So I'm going to make a little table here just to demonstrate that. Two cases. So two columns, right? So one is A larger than 0, so the parabola opens up. And the other case will be A less than 0, the parabola opens down. Okay. So these are the two cases. So in these cases, we have two X-intercepts. Okay. Now, the second case is the parabola touches the x-axis only once, okay? Touches only once. So when the discriminant is 0, the parabola touches the x-axis only once, okay? And we have those cases, right? It could be touching in the case of less than 0, A is less than 0, or A is positive, okay? A could be positive or negative, which means It could be open up or open down. For example, I can have a function that touches, right? Let me give you that example. Touches once, right? But it opens up. It opens up. It could also be it touches once, opens down. So let's see a case that's opens down. Okay. And make a little adjustment on the view. Okay, so in the case the parabola touches x-axis, it could be opening up, touches the curve, touches the x-axis once. It could be opening down, touches the x-axis once. Now, the third case, if the discriminant is less than 0, right? If the discriminant is less than 0, and then we will have no touch with the x-axis. We'll have no touch to the x-axis, right? So I'm going to give you some of those cases, right? So hold on. One case, which is above. Okay, so these are touching, right? So let's do above. Above, right? It could be below. Okay, so opens down, but never touch the x-axis. So these are the cases, it's the 3 cases we could encounter according to the discriminant. And this is what we know about the function. This is what we know about function. In each one of these cases, right? So in the first case, the discriminant is positive. How many x-intercepts do we find? We should have 2, right? So in this case, there are 2 x-intercepts. There are 2 x-intercepts. Okay, there are 2 x-intercepts, plural, 2 x-intercepts. And how to find them? Right? How do we find these x-intercepts? How do we find them? Right? We know that in these cases, the points are on the x-axis, right? So x-intercept is really the point that crosses, that's the point where the curve crosses the x-axis, and we know the coordinates, right? So we understand. So let's mark these 2 points. I think we have these marked before. So let me see if I can give you those examples. Okay, let me see if I can find those examples. Here we go, right? We could totally use this example, right? Opens down. This example has it's an example of opening down. So let me put it here. Opening down. We have opened up, right? Do we have opened up? We certainly do, right? We have the case of opening up across the x-axis. And here we go. So this is the one I'm looking for, right? So we have these cases. We saw those cases before. Right there, right? So you can see x-intercepts is the place where the curve crosses x-axis. The points are, right? When the input is certain number and the output are 0. So input, output. That's the meaning of x-intercept. Okay, then we're going to talk about how we find them. Okay, so we're going to talk about how to find them momentarily. The second case, we have exactly 1 x-intercepts. Okay, so there's one x-intercept. So we have only one intercept. Singular. Did we have those cases? We studied one case before. Okay, so let me grab that for you. This one. This is the case that opens up, right? It has the x-intercept, right? So I'm going to put it right here. This is the case we did before. For the other case, we actually, I don't recall we have an example that we did this, but I can totally give you one. This example is x minus 3 squared, right? X minus 3 squared. And this one is basically x plus 2 squared, right? So we have these examples and there's exactly one x-intercept, right? Now we're going to talk about how to find them, right? So once again, how do we find them? How to find it, right? So we're going to talk about that. In the third case, right, there's no x-intercept, no x-intercepts. No x-intercept, right? And how do we recognize it, right? How to know? How do we know, right? How do we know there's no x-intercept? So this is the task of this section, right? We understand what x-intercepts are, if there's any, right? And we also understand how many we could possibly have. We could have 0, we could have 1, we could have 2. So in this section, we're going to talk about how to find quadratic, how to solve quadratic equations. Okay, so we're going to start out to take a look at this quadratic equation. So quadratic equation is basically, we know the function, right? And the input is x and the output is 0. So quadratic equation is established when we're looking for all possible input, right? So the goal is to identify all possible input, okay, such that the output, okay, the output is 0, such that the output is 0. That's the task. Okay, we typically will say solve for x, right? Solve for x. So that's the wording. The wording basically is saying that if, right? The meaning is if, oops, right? If the output is 0, right? If the output is 0, find all possible inputs. It could be 2, it could be 1, it could be none. Okay, so that's the meaning. So let's look at some examples. The general method, there are 3 methods. The first method is a factoring. The method of factoring. Okay, the method of factoring. Factoring method probably is something you have learned. It's probably something you have learned, right? So let's look at some examples. Example number 1, suppose we say solve for x, right? Solve for x, that's a typical wording. And then we're given a quadratic equation. So here is x squared, x squared, right? Minus 5x plus 6 equals to 0. If we use factoring method, so we will factor, we'll make, for factoring method, we have two major steps. First, you have to check one side of the equation is 0, right? The output is 0. But what if it's not 0? If it's not 0, you're gonna make it 0, right? We're gonna make it 0. We're gonna see an example in the future, okay? Very soon. So one side is 0, right? We have made the 0 is given. So we have a 0 on one side. And then we just go ahead and factor. Regarding factoring trinomial, there's a, I have taught factoring, okay? I know there's many different ways of factoring. If you ask me how I do the factoring, which I'm going to present it to you here, and this is how I'm going to do the factoring. Okay, so now I'm going to show you. Factor. I understand you have many different ways of factoring. So first, I'm going to factor this piece. How do I factor this piece? I have certain procedure. Okay, first of all, I know the number before it is 1, right? It's 1. And this is the constant. This is the constant. So what I would do is that I'm going to put a, you see, 1 is equals to 1 times 1. Okay, 1 multiplied by 1. Okay, so 1 times 1. That's how you read it. Okay. This 1 is equals to 1 multiplied by 1. Okay, so that's what's in my mind. And next, I'm looking at the 6. Okay, 6 equals to 2 times 3. So I have 2 times 3. 2 times 3. Okay, I will set up 6 is equals to 2 times 3. 1 equals to 1 times 1. And what I'm going to do is I'm going to do a cross product, cross multiplication. This is how it's been done. Okay, so I'm going to show you with the software, on Zoom. We're going to multiply these two numbers. Okay, 1 times 2 is 2. 1 times 2 is 2. 1 times 3 is 3. Okay, so here, 1 times 2 is 2. 1 times 3 is 3. And we're going to take 2 and 3, we add them up. So we're going to add these two numbers. Okay, so we're going to add these two numbers. 2 plus 3. 2 plus 3 equals to 5, right? 2 plus 3 equals to 5. We want this procedure produces a number that matches the number in front of x precisely. Obviously, we did not match it precisely. We have a -5, we have a +5 here. Okay, so it doesn't work. If it doesn't work, we'll continue to try it. Okay, say I'm going to make this to be 1 times 6. 1 times 6 is going to equals to 6. 6 equals to 1 times 6. So 1 times 1. So this is going to be 1 times 6. That's going to be 6. So 1 plus 6 equals to 7. And 7 does not match -5 either. So what I'm showing you here, this is a trial and error process. Okay, so finally, of course, we're going to try -2 here. And we're going to try -3 here because -2 times -3 equals to +6, right? So as a result, 1 times 2. Okay, so let me use the software here. Okay, so 1 times -2 is going to give us a, right? It give us -2. So this is going to be -2. Okay, 1 times -3, right? It's going to give us, what does it give us? It's going to give us -3. Okay, and -2 plus -3 equals to -5. So we finally made the match. Once we made the match, okay, so all these trial and error, sometimes you find yourself try and error, and sometimes you find it right away, right? So it can be, it can be different from one person to another. But feel free, as you can see, this process is try and error. It's try and error. Okay. So now once we found these matches, now it's time to make up the factors, okay? So let me just line them up nicely. Okay, this is -3. So just like that, okay? And over here, let me just make it something like that, make it nicer. Okay, so the cross product, the crossing, we have hard time to find the symbol for the software to do that. So I have to use the Zoom software to do this, right? So to do the cross multiplication. Okay, so that's complete. So this is the picture you can draw on the paper. Okay, and this is how I learn to do the factoring. Okay, simple factoring. So now we found the match. So let me repeat the process one more time. 1 is equals to 1 times 1. 6 equals to -2 times -3. You need to make sure the setup is correctly. It's like the initial setup before you play a game. Okay. Excuse me. And then the rest is a routine. Cross multiplication, add the two numbers, and your goal is to match this number with the number in front of X completely. Okay, you cannot have +5. If you have +5 does not match -5. You have to match -5 precisely. So once the match is made, okay, and we then can construct our factors. Let's see how we construct the factors. From the first row, right? In the first row, I'm going to construct a factor. In the second row, I'm also going to construct a factor. So that's why, we set it up this way. So what does the first row tell me, right? The first row tell me that I have two numbers, 1, -2. The 1 is going to be going with 1 times X, okay? -2, that's -2. That's what the first row gave me. The second row gave me, there's 1, there's -3. So the first number will be 1 times X. The second number is -3. Okay, I hope this is clear. And now we found our factors. Of course, 1 times X -2 is X -2. So this piece is X -2, and this piece is X -3. And by this time, our factors are found. Okay, so our factors are found. And we got X -2 times X -3. X -2, X -3 factored. You can always check. Okay. You can always check whether your factoring is correct by FOIL. Okay. So you take X -2 times X -3, and you can check it. Okay. So when we check it, we basically just a FOIL, right? X times X, X squared, right? X times -3 is -3X. -2 times X is -2X. -2 times -3, that's a +6. So in the end, if you can check it, and that will be double assuring, right? -5X + 6. So that's how to do factoring. And this is the technique I teach if I teach factoring for quadratic function, okay? Many of you have learned in many different other ways, and I do not have any objection that you use those other ways, okay? You use any other ways. So now let's come back to solve equations, okay? So now we continue to solve the equation. So I'm gonna show you how to show work. Okay, solve this equation, right? And the second step, we're gonna do the factoring. If you want more practice for factoring, go find an elementary algebra textbook or intermediate algebra textbook. There are plenty of exercises for you to do. And the factored, right? However you do it. If you want to show the work nicely so your reader can read it. If you don't show this factoring process or you do it on a scratch paper, it usually doesn't bother anybody, right? Especially as you get moving towards a calculus class. These steps, as long as you get it done right, and usually these steps are not being granted a lot of points. So as long as you do it right, you're fine. Okay, so when we get to this point, we get to use principle number 5, right? Principle number 5 says if, right, one quantity multiply another quantity equals 0, right? Zero product property, right? Then A is 0 or B is 0. Okay, so that is principle number 5, and we're using that, right? So we got A times B, right? So the next step is just saying, okay, X minus 2 equals 0, or X minus 3 equals to 0. Okay, and next, X equals to 2, or X equals to 3. So the equations are solved, okay? Depends on how the questions is asked, really, okay? For example, if the question asks you, solve the equation for X, right? In this case, you're done at this point. But if the question goes, if the question is the following, right? The question says, oh, find the X-intercepts. Find the X-intercepts, right? If you're asked to find X-intercepts for this function, right? Like you have seen those examples before, right? Find the X-intercepts where you say, oh, they might say for this function, right? What do? If the question is asking you to find X-intercepts, then you have to go a little further. You would say, okay, to find X-intercept, you're gonna set this guy equals to 0. You probably tell the reader, set it equal to 0, and you find the solution, right? You find the solution, and then you have to answer. Then you say the X-intercepts are, right? You have to tell the reader the X-intercepts are what, right? The X-intercept are 2, 0, and 3, 0. You see, it depends on how the questions are asked. Okay, we understand the nature of the question, but it doesn't necessarily, because in the first question, they really just asking for what are the numbers that make that statement true, right? It didn't ask for X-intercept. So sometimes these things happen, so you don't have to go, further. But if it asks you for X-intercept, typically it's in the context of function. And this is how you answer the question. So in this case, in the first case, the answer found here, you're done. In the second case, you're going to give the 2 points that are x-intercepts. Okay, so this is the first method. This is the first method. Okay, factoring method. Factoring method. Okay. Now, second method. Method 2. Method 2. Method 2 is completing a square. Completing a square. Okay, solve by completing a square. Okay, so how do we solve it? Right, suppose we solve the same question. We solve the same question, right? We're going to solve for, we still work on example number 1. Completing a square. So how do we complete the square over here? Well, in order to do that, right, we will set up our equation. We're going to subtract 6 on both sides. So this is -6. And we're going to make the one side to be perfect squared. Do we know how to make a perfect square? Oh, let's try it, right? We're going to add a number. We're going to add a number on both sides, okay? And that number is going to make a perfect square on one side. And what that number should be? Well, we know how to do it, right? We take the 5 divided by 2, and then we square it. And we add the same number on both sides. So the narrative is that if this is true, then this is true, right? If this is true, then this is true. We add the same number on both sides. So these are really principle number 4 being used, right? Principle number 4 being used. So what are principle number 4? Let's recall what's principle number 4. Actually, principle number 3, sorry. Principle number 3. If A is the same as B, right? Then A plus C equals to B plus C, right? That's principle number 3. That's principle number 3. Okay? So we've been using principle number 3 all along, right? We subtract 6, adding, 5 halves squared. And now by this time, the left-hand side is a perfect square. The left-hand side is a perfect square. Okay, so this is the perfect square. 5 over 2, that's, 5 half. So we get an x minus 5 half squared equals to, on the other side, we have to do something. We have to do something, right? And what do we get? What do we get? We get a -6 plus, and that's going to be 25 over 4. 25 over 4. What does 25 over 4 equal to? Well, we may find the common denominator, right? The common denominator is going to be 4. So -6 is going to be 24 over 4 plus 25 over 4. Okay, so in the end, we get a quarter, 1/4, right? -24 plus 25 equals to 1. So now we have these perfect squares on one side, and the other side is a quarter. So this is using completing a square method. Completing a square method. We're not done yet. We're not done yet. Okay. And the next step, we're going to take square root on both sides. Take square root on both sides. Take square root on both sides. And then what do we get? The left-hand side will be the absolute value of x minus 25. Okay, on the other side, the square root of a quarter is half. Okay, by the way, here, from this step to the next step, if you want to check your work, go for it. You can check your work by foiling this piece to see if you go back to the previous. Okay, it should go back, otherwise you have to do it all over. Okay, you have to do it all over. Okay, so you can check your work anytime you want. You can check your work anytime you want. Okay, so that's just something you probably would put it down on the on the scratch paper, right? Don't mix up with your formal work. Okay, so I'm going to give you a version of formal work, right? So remove all of these things. All right, we're almost there, right? So this is an absolute value equation. This is an absolute value equation. Recall, right? The absolute value equation, right? Recall the absolute value equation. Remember we had baloney like this, right? Say this one equals to half, right? And then the solution that the baloney would equals to, or omega equals to plus minus half, right? This is what we did this in absolute value equations. If you need to watch that, please go for it, right? It's all available, right? So you treat this as omega. Absolute value omega is half. So omega can be either positive half or negative half. Okay, so you get to the next step, right? Which is x minus half, 5 half is equals to negative half or positive half. Or positive half. Okay, and then you solve these two equations respectively. And the first one, you add, right? You add 2/5 on both sides. Adding 2/5 on both sides. So we're using principle number 3 one more time. So we're using principle number 3 here. You see that? We're really using principle number 3 here, right? So basically it says if, right, if this equals negative half and we add a 5 half. So 5 half, we add on both sides, right? Subtract half, right? Subtract half. And this is going to be 5 minus 1. That's going to be what? That's going to be what? That's going to be x equals to 4 half, right? 4 half x equals to 2. 4 divided by 2 is 2, right? And the other one, we have to solve the other equation, right? We also add 5 half. And this time we're going to get x equals to 5 half plus half. Plus half. 5 half plus half, that's that take us to the next step, which is 4. Right? Then x equals to 3. We got the same answer. We got the same answer. Right? And you're done because this is just asking for a solution. They didn't ask for x-intercepts, right? So how do you show your work, right? How to show work? These are the questions I often get, right? If you show work on this one, right? So I'm going to copy the entire question. So let me just show you how you should show your work. Okay, because that's a perpetual question our student ask. Okay, it's not just you, right? How many steps do I need to show, and so on and so forth. In this case, let me tell you how much work I recommend you to show. Okay, depends on your professor. So I can only just recommend how I would show the work. I will show the work. When you show the work, right? You don't need to show these. You don't need to show these. Okay, you don't need to show these either. You should check it by all means, on your scratch paper. Okay, you can check it on your scratch paper. So like these pieces of work, right? And you don't need to show these, and you don't need to show these either. That's how you show work. Some of these lines, you can make it shorter. For example, right? From this line to the next line, you can totally do these on your scratch paper and then just give this piece. Okay, so this step, if you're certain you've done it correctly, you can just leave it like that. Okay, so some of these lines, for example, this line is totally optional. Okay, so this line is optional. Okay, it's optional. Okay, so this is the second method. This is the second method of solving quadratic equations. The third method, right? The third method is a quadratic formula. The third method is a quadratic formula. Okay, so method 3, quadratic formula. Okay, so we're going to use the same. We're going to use the same example to solve quadratic equation by quadratic formula. What is a quadratic formula? Right, so what is a quadratic formula? First of all, you need to understand what quadratic formula is for. Okay, quadratic formula is for a specific situation. And that situation is a times x squared plus bx plus c equals to 0, where a cannot be 0. You will find out this requirement is absolutely crucial. Okay, quadratic formula is for this quadratic equation. You see, on this equation, one side is 0. Okay, so something quadratic form equals to 0. So you must have 0. And secondly, you have to identify the parameters a, b, c. So x is going to equals to what? Okay, this formula, I think some of you can sing a song about it, right? You have a 2 times a, you can see 2 times a in the denominator, right? If a is 0, then it doesn't make sense. So we have to require a is not 0. On the top is a negative b plus minus square root of b squared minus 4ac. Okay, so that's quadratic formula. Quadratic formula can work for solving any quadratic formula. For example, if you just stick to quadratic formula, you can solve any quadratic equation regardless. But sometimes, right, sometimes factoring seems to be just much faster. Okay, and some other times, like in our previous lessons, you have already done the completing a square, right? So you can just utilize it, right? You can just utilize the completed square, right? You can see there's an advantage. You also get the answer sooner. So it's really, it's totally up to you, especially we have so many choices, right? So let's look at this case. Let's look at this case. If you choose to use a quadratic formula, right? So I'm going to bring this formula right down here, right? Suppose we apply this formula to this equation, right? The first thing we need to identify, you need to make sure, the first thing you need to make sure you have a 0 on one side. Okay, it can be on the left-hand side, it can be on the right-hand side, right? So here we have a 0. You must have a 0. So when you use a quadratic formula, you have to have a 0 on one side. And then you identify the a, b, c. So a equals to 1, b equals to -5, c equals to 6. The steps I recommend, the step I personally recommend is the following. I'm going to take a discriminant, okay, discriminant. The discriminant is b squared minus 4ac. b squared minus 4ac. I do this separately because I make my steps clearer and the calculation doesn't seem to be so crowded, right? So in this case, I'm going to work out my discriminant. My b is -5, so -5 squared, b squared, minus 4 times a is 1, c is 6. Right, I'm just go about my calculation. So that equals to 25 minus 24 equals to 1. Okay. Once I get my discriminant settled, right? The rest is just, I can just replace this piece by discriminant because I don't have to calculate it all over again, right? And then I'm going to plug in. B is -5. Right? D is 1, already found it. A is 1. Okay. When I do substitutions on the first step, I will not mess up with it. I'm not going to mess with it. I'm just putting numbers honestly and straightforwardly into the formula. Why? Because if I have time to come back to check my work, say on the exam, I can quickly check it instead of manipulating over it, right? The more straightforward, the better. And the next step, I'm going to simplify. So -5 is 5, square root of 1 is 1, and 2 times 1 is 2, right? So now I anticipate I'm going to have 2 solutions, right? Because of +1 minus 1. So I have x sub 1, that's 1 solution. That's going to be 5 minus 1 over 2. It doesn't matter which one you call it, x1, right? And that's going to be what? 5 minus 1 is 4. 4 divided by 2 is 2. My second solution is x sub 2. And that's going to be 5 plus 1. Right? 5 plus 1 divided by 2. And that's going to be 3. That's going to be 3. And the solution found. And then you can tell the reader solutions are, right? X sub 1 equals to 2. X sub 2 equals to 3. And you're perfectly okay. Okay, so in terms of how to show work, right? In terms of how to show work, well, this is how you can show your work. The nicer, the better, the cleaner, the better. Okay, the nicer, the cleaner, the better. Okay, so now I want to give you the alternative formula, which is over here. Right, this formula, and I put a discriminant right here, and I'm going to tell the reader what is discriminant. So that's my favorite way of doing it, and you don't have to, but let me tell you the advantage. The advantage is that once you know the discriminant, it's calculated nicely and cleanly, you can also tell how many solutions are expected. Okay, how many solutions are expected? Just like quadratic function. Okay, just like quadratic function. Quadratic equation, solving quadratic equations, there are 3 cases. So I'm going to put it on. So now we have talked about all 3 methods, right? We have talked about all 3 methods. Okay, we have just covered the first case, the discriminant. When the discriminant is positive, okay, there are 2 solutions. Okay, if discriminant is positive, the quadratic function has 2 x-intercepts, so they're consistent. Then you say, oh, there are 2 other cases. Absolutely. If discriminant is equal to 0, right, it touches x-axis only once. In this case, there is one solution. Okay, we're talking about two real number solutions. Okay, real number solutions. Okay, one real number solution. The last case, if discriminant is negative, right? There are two complex number solutions. There are two complex number solutions. And the first example we did here actually covers the first case, All right. So let's look at other cases. Okay, we're going to still doing the three methods. We're going to do the three methods. So we're going to do example number 2 with the three methods. Okay, example number 2. Okay, we're going to solve for x, right? And this equation goes like this. It's x squared minus 6x plus 3 equals to -6. Okay. All right. So it's a quadratic equation. We can solve it in different ways. Right? The first method, method 1, of course, factoring. When we do factoring, we need to ensure one side is 0. Why? Because we're going to use principle number 5. Principle number 5 says if a times b equals to 0, right? So we need a 0. So let me type the principle number 5, right? Principle number 5, if a times b is 0, right? Then a is 0 or b is 0. Okay, so factoring meaning we're heading towards using principle number 5. And to use principle number 5, we need to have 0, right? You don't have to type this for your reader, but in your mind, you need to have it. So we don't have a 0 on one side, right? So what do? We're going to make 0. So the first step, we're going to make 0. How do we make 0? We use principle number 3. What is principle number 3? Okay, look at your notebook, find principle number 3. Principle number 3 said if, right, a equals to b, then a plus c equals to b plus c. Sorry, c, right? That principle. And we have a is the same as b, right? This is whole piece is a and this is b. A is the same as b, right? Because this statement basically is saying if a is the same as b, if left the same as right, right? Solving for is always if statement. So here we go. We're going to make 0 on one side. How do we make 0? There are multiple ways to make 0, but the easiest way here is add 6 on both sides, right? So we're adding 6 on both sides. And as a result, we get x squared minus 6x plus 9 equals to 0. And then we're going to do factoring. Okay, so let's see how we do the factoring, right? Similar setup. Okay, trial and error. So 1 equals to 1 times 1. 9 is equals to 3 times 3. 3 times 3. Right? Cross multiplication. cross multiplication. Okay, how do we do the cross multiplication? We've done that earlier, right? But some of you may not be familiar with this method, right? Cross multiplication. So 1 times 3 is 3. 1 times 3 is 3. 3 plus 3, what do we get? What do we get for 3 plus 3? We get 6, right? We get 6. Does 6 match the number in front of x? It doesn't. Okay, try again, right? 1 equals 1 times 1, 9 equals to -3 times -3. -3 times -3 is a +9. So cross multiplication, 1 times -3 is a -3, 1 times -3 is a -3, -3 plus -3 is -6. We found it. We've made the match. We made the match. Once we made the match, we're going to compose our factors. We're going to compose our factors. Okay, let's compose our factors. So what are our factors? The first row, right? 1 times x minus 3. So this piece is going to be x minus 3. The second row, oh, it's also x minus 3, right? Oh, we get x minus 3 squared. We got the perfect square. We got the perfect square. By accident, or maybe not, right? But that's what we got. We got our factors. We got our factors. This piece of work can be done on scratch paper, depends on what your professor requires. If you do show the work, make sure you show the work nicely and neatly so any reader can understand and cannot reduce a point from your work. That's my principle, right? So depend on how much work your professor wants you to show. And sometimes I think by the time you're in calculus class, these work should be shown on the scratch paper and just put it away, right? And your next step is just going to be x minus 3 squared equals to 0, right? So if this is true, then this is true, right? If that is true, and the next one is true. So this is true. So what number time itself is 0? Something square is 0, then something has to be 0, right? So if x minus 3 is 0, if x minus 3 squared is 0, x minus 3 must be 0. And as a result, x equals to 3. You don't need to take square root, right? It's already there, right? So the narrative, I want to give you the narrative. This is the narrative, right? If something squared equals to 0, then that baloney has to be 0, isn't it? That is always true, right? Because only 0 squared is 0, right? So that's your narrative. That's your narrative. And you already found the answer. You already found the answer. Okay, you already found the answer, right? So that's how you show work. And there's another version of the work you can show. Okay, there's another version of the work you can show, right? For example, if I show this method, oops, right? I would just, this is how I would show work. Okay, so I'm going to do some trimming. Okay, I'm going to remove that. I'm going to remove those, right? That's it. And I can remove that too. Nice and clean. Okay, nice and clean. And you're finished. You're finished. Okay. That's the first method. In this method, how many solutions do we have? One. Okay. How many solutions do we have? One. Okay. Let's do method 2 on the same. Okay. So method 2. Completing a square. Completing a square. Okay, completing a square. So how do I complete a square from this? If this is true, when I'm completing the square, I'm going to move everything but the term with x. So term with x, I'm going to leave it on the left-hand side. So I'm going to subtract 3. Okay, so the next step I'm going to get, I'm going to keep the x squared minus 6x equals to, I'm going to subtract 3 on both sides. So it's still principal number 3, subtract 9. And then I'm going to add something on both sides. And that's something I'm going to choose it to be to make a perfect square on the left-hand side. So I'm going to choose it to be 6 divided by 2 and then square it. I'm going to add the same number on both sides. So the choice of this number we're adding on both sides is to make this to be perfect square, right? We talk about that method, completing a square. So now, of course, you can write 3 squared. Of course, you can do that, right? Of course, you can do that. So the perfect square we get is going to be x minus 3 squared. On the right-hand side, what a pleasant surprise. -9 plus 3 squared. That's -9 plus 9. That's a 0. That's a 0. Ah, we're back to the same place. Boom. Same answer. Same answer. Okay, that's method 2. Okay. We'll get the same answer whichever method you use. Let's look at method 3. Method 3. Okay, we're going to use a quadratic formula. Quadratic formula. Do we still remember quadratic formula? Of course you do. I'm sure you do. Right? So let me bring those formula back with us. Where are they? Right here. No, so we need to understand the quadratic formula, what it's for, right? What it is for. Don't forget. Well, okay, you don't need to show these to your reader, but you need to know. You need to know. Okay, so suppose we're solving the same equation, example number 2. What do we get? Well, before we use a quadratic formula, we have to make sure one side is 0. And now we don't have any side equals 0. So we have to make 0. How do we make 0? We use principle number 3 or principle number 4. Right here, the easiest way would just be adding 6 on both sides. Okay, so we're adding 6 on both sides. So we're going to have plus 9 equals to squared. And we identify, A, B, C. Okay, A is 1, B is -6, C equals to 9. And I'm going to find discriminant, right? You know my little favorite way of doing this, okay, to keep it nice and clean. So that's B squared is -6 squared. Minus 4AC, 4 times 1 times 9. Let's see what we get. -6 squared is -6 times -6. That's a positive 36. 4 times 9, that's a 36 again. Oh my God, we got 0. What a pleasant surprise. That's going to make our calculation so much easier, isn't it? And then we can use a formula. In this case, I'm going to just use the latter one. They're the same thing because I already found D, right? D is 0, right? That's gone. So plus minus 0, that's gone. And B is -6. Okay, I'm going to replace B by -6. A is a +1. And simplify, we get 3. So we get exactly one solution. You see, it doesn't matter which method you use. Right? So this is a case 2 with 3 methods. Case 2 with 3 methods. Let's look at case 3. Case 3. Okay. What is a case 3? When the discriminant is less than 0. Okay, I'm going to make up a question to do that. Okay. Now, I'm going to give you another example. On this example, we're going to use all 3 methods. Example number 3. Okay, once again, solve for X is an if statement once again, right? The equation we have is X squared plus 4X plus 5 equals to 0. So first, this doesn't seem to be a very complicated equation, right? So I would naturally try factoring. Right? So method 1, method 1, right? I'm going to try factoring. We're going to try factoring. Now, to factor this piece, right? The coefficient is 1, so it's 1 times 1. 1 times 1, right? 5 is equals to, gosh, what is 5 equal to? 1 times 5? It cannot be split. 5 is a prime number, right? Excuse me. 5 is a prime. So I'm gonna try it. 1 times 5. Right? So I'm gonna do my cross product. Okay, so 1 times, I'm gonna change the color. How about that? Right? So 1 times 1, 1 times 5. And then what do I get? 1 times 1 is 1. 1 times 5 is 5. 1 plus 5. 1 plus 5. What does 1 plus 5 equals to? 1 plus 5 equals to 6. It doesn't match the 4, right? So I have to do it over. Okay, so let me try negative. I'm going to try -1, -5, because this is not going to work either, right? So I try and I keep trying and I keep trying, right? This time it's -6. It doesn't work. I cannot find the match with this simple method. What does this tell us? Does this tell us that we cannot factor? Does this mean we could not factor? What do you think? The answer actually is no. We can factor. It's just we cannot find the factors easily. We can. Yes, we can. Because I'm going to show you the factor. I'm going to show you the factor later. At this point, you cannot say it cannot be factored because that's not true. Their mathematical theory such as the fundamental theorem of algebra tell us this can be factored. This can be factored. It's just we cannot find factors in this way. That's all. But the factors do exist. But at this moment, we probably will give up factoring method because factoring just makes it so difficult, right? The simple way doesn't factor, but we know there are factors. In fact, they are factors. Okay, they are factors. Okay, we'll show you. We'll show. I will show you. I promise you. We'll come back here. All right. Then what do we do? Completing a square. In this case, method 2, we can complete a square. Okay, so we're going to solve by completing a square. Okay. Promise you, we will come back. To do completing a square, of course, we're going to move -5 to the other side. So we're going to have -5, principal number 3 is used. And then we're going to add a number on both sides, same number, and that number is going to be 4 plus 4, right? And the left-hand side, if you factor the left-hand side, you're going to get x plus 2 squared. If you need to pause the video, go for it. And the right-hand side is -1. Okay. Now, what you're going to see is that you're going to take square root. You're going to take square root on both sides. Square root of -1. Well, many of you know that's I, imaginary number. That's an imaginary number. This already tells us there are no real number solutions. So at this moment, okay, actually at this moment, we already know there are no real number solutions. Okay, and there are two complex number solutions. Okay, so now let's go find them. Let's go find them. So we got absolute value x plus 2 equals to I. Okay, and now, okay, just like how to solve absolute value equation, you're going to have x plus 2 equals to plus I or minus I. So in the end, your solution are going to be -2 plus or minus I. So these are the two complex number solutions. Okay, one is -2 minus I, the other one is -2 plus I. The two complex number solutions. Okay, that is, if you want to separate it, okay, you have one solution which is x equals to -2 minus I, and the other one -2 plus I. These are the two solutions. Third method, method 3. Method 3 for the same question, quadratic formula, right? We're going to use a quadratic formula, right? So once again, we need to understand what quadratic formula is for. Okay, quadratic formula is for that. You have to have a 0. Oh, we already have a 0. Great. And then the rest is just identify A, B, C, right? So what is A? A is 1, B is 4, C is 5. And then, you know, my little favorite procedure, okay, to keep it nice and clean, right? So we got 4 squared minus 4 times A times C is 5, 16 minus 20. Excuse me, 60 minus 20, that's a -4. This already tell us, okay, at this moment, right, at this moment, we already know there are 2 complex number solutions. We just have to get to them. Okay, there are 2 complex number solutions. And let's find them. Right? Since we already have the D, right? So I'm just going to use the ladder formula, and this is going to be -4. And B is 4, A is 1. We put it in. Now what do we got? Right? So the denominator is a 2. Numerator is -4 plus minus, right? So how do we write it square root of 4 as something? You know, we can write it as a root 4 times root of -1. Okay, and root of -1, that's I. But we want to put this I in front of it. Why? Because if you're not being careful, let's make the fonts larger. If you're not being careful, right, when you're writing it, especially when you write it by hand, if you're not being careful and you make this too long, and that will be a mistake. For that reason, okay, I'm going to put the I in front of it. So this will avoid a lot of problems. Okay, but square root of 4 is 2, right? So you can write I times 2, or just 2 times I. 2 times I is fine. Okay, but sometimes you still have a square root there. So you want to write the I in front of it. In this case, you can write it in front or behind. Okay. In other cases, okay, in some other cases, in the future, you might encounter like square root of 3 of I, right? In this case, we will highly recommend you put the I in front, square root of 3 behind it. Okay, so this is highly recommended, and you will see a lot of textbooks actually practice this. Okay, in our case, we don't have any trouble. Okay, but in the case you might make this too long, just don't do it. Make the I in the front. All right, so that's clear. And next, we're going to simplify. Okay, when we simplify this, we have to be very careful. Okay, we're taking the 2 divided into -4 plus minus, we're taking the 2 in the denominator divided into 2 times I. That's the operation. So in the end, you get -2 plus minus I. And that's our answer. So X equals to -2 plus I minus I. Okay, so let's go back to the smaller funds and to look at the entire question being solved. Okay, so look at the entire question being solved. Okay. I would probably remove these. Right? So that's the work you will show. You can remove these, remove those. That'll be fine. Optional. Okay, don't keep this one. Okay, just an example. Okay, that's optional. If you tell the reader or not, that's optional. All 3 methods in all 3 cases right? You can see the discriminant is very, very useful. It's very, very useful. So now let's go back to the top. Let's go back to the top, right? As we discussed earlier, for quadratic function, for quadratic equation, we have these three cases, right? For quadratic equation. Okay, so let's summarize. The three cases. Okay, and these are for quadratic what? For quadratic what? We have said this earlier, right? To the very top. For quadratic okay. For quadratic equation, it doesn't matter which method you use. These three cases applies. If you have discriminant positive, you're going to have two real number solution. If the discriminant is 0, you have one real number solution. If discriminant is less than 0, you have two complex number solution. Okay, in comparison, for quadratic function, right, which just a function, right, where a cannot be 0. These three cases has some partner, have some what do you call it? Comparable conclusions. There are two X-intercepts. There are two X-intercepts. Okay. In the second case, there's one X-intercept. Okay. One X-intercept, so singular. And in the last case, there's no X-intercept. No X-intercept. Okay, it doesn't matter in plural or singular, I believe. Right, so you can see these three cases very much dependent on the parameters ABC for equation, and that's for function. That's for function. Okay, I hope that helps. And if you want to use a quadratic formula, and here you go. Here you go. Quadratic formula will solve any quadratic equations for you. Okay, we'll solve any quadratic equation for you. Okay, so that's a summary, and we've done so many examples, and of course you have homework to do. If you have any questions, please don't hesitate to reach out to me. And thank you for watching.